Look at this building. It has been hanging off a cliff for more than 1,000 years. Those thin wooden posts? Your brain immediately assumes they're the only thing keeping it from falling. They look fragile, temporary, almost wrong. But here's the unsettling truth. Those posts are not what's holding this temple up. What actually supports this structure is almost completely invisible. And once you understand how it works, the building becomes more disturbing, not less. Because this temple doesn't survive by defying gravity. It survives by understanding gravity better than we do today. This is Xuankong Shore, the Hanging Temple. For roughly 15 centuries, its wooden frame has survived here through countless repairs and renovations. Earthquakes have shaken the ground. Storms have battered the walls. Yet it still hangs there, defying every instinct your brain has about gravity. At first glance, this structure shouldn't exist, and for a long time, no one could fully explain why it did. Only recently have engineers been able to model in detail what's actually happening inside the mountain. Over the last few years, engineers and historians have taken a closer look at how this structure actually works. Not through legend or speculation, but through detailed structural analysis and modelling. And what they found forces you to unlearn almost everything your eyes are telling you. The most visible parts of the temple are not the most important ones. The strongest elements are hidden, and some of the most reassuring features exist mainly to calm human fear, not to hold up the building. Because what these monks achieved wasn't just building a temple. They solved engineering problems that modern architects still struggle to replicate with the same elegant simplicity. By the end of this video, you'll understand why this temple represents one of humanity's greatest engineering achievements, and why the solutions hiding in its wooden joints could revolutionize how we build today. But here's the first thing that doesn't make sense. How is this wood still here? Think about this for a second. A typical wooden structure exposed to the elements might last only decades, maybe 50 years if you're lucky, especially in mountain conditions, with temperature swings, moisture, and constant weather battering. The structural concept of this temple has survived for roughly 1,500 years. While individual beams and surfaces have been replaced many times, the underlying system, how the building works, has remained essentially unchanged. It's like maintaining a living organism rather than preserving a fossil. So what's the secret? Most people think ancient preservation was about some magical wood species or secret chemical treatments. They imagine monks had access to some super timber that modern science has forgotten. The truth is far more elegant, and it reveals the first principle of genius engineering: work with nature, not against it. Here's what actually keeps this wood alive. 3 survival strategies that any engineer today would recognize as brilliant environmental design. First, location is everything. This temple isn't just stuck randomly on a cliff face. It's tucked into a natural recess under a massive rock overhang. That overhang acts like a giant umbrella, protecting the wood from direct rain, snow, and the harsh mountain sun. It's like the cliff itself is sheltering the temple. Second, the monks chose their materials wisely. They used local timber species that were naturally suited to this environment, not because they were magical, but because they understood their local ecosystem better than any modern consultant. Third, and this is crucial, they never expected the original wood to last forever. Historical records show continuous maintenance and repairs across multiple dynasties. The Ming and Qing dynasties both made major renovations. What you see today isn't untouched ancient carpentry. It's a living structure that's been carefully maintained for centuries. It's like the ship of Theseus, but for buildings. Replace the parts, keep the system alive. Modern construction often treats maintenance as failure. These monks treated maintenance as part of the design. The goal was never permanence of materials, it was continuity of the system. But even the best preserved wood in the world can't explain the real mystery. How do many tons of building material stay suspended in mid-air? For that answer, we need to look where your eyes can't see. And that brings us to the second secret, the one that will make you question everything you think you know about this temple. Everyone who looks at this building sees the same thing, those thin vertical posts stretching down from the temple toward the ground. Your brain immediately assumes those posts are holding everything up. It's logical, it's obvious. It's also completely wrong. Here's the mind-blowing truth. Many of those eye-catching vertical posts are not part of the primary load-bearing system. Some provide secondary support, others mainly serve visual and spatial purposes. The real structural work is happening somewhere else entirely. So what's actually holding up this massive structure? The real skeleton is inside the mountain itself, not below the temple. Hidden deep in the cliff are horizontal beams that do something your eyes never register. They turn the mountain into the foundation. These beams are the true load-bearing members. Everything else plays a supporting role. Picture this scenario. You're a monk with no power tools, facing solid rock. You need to create an anchor strong enough to hold an entire building. How do you do it? The answer is pure mechanical genius that predates modern engineering by 1,000 years. Here's how it works. The monks drilled holes deep into the cliff face. Then they inserted wooden beams with specially carved wedges at the ends. When they drove the beam into the hole, the wedge forced the wood to expand and lock against the stone walls. Sound familiar? It should. This is essentially how modern expansion bolts work. The same principle contractors use today to anchor heavy equipment to concrete walls. Except these monks figured it out in the 6th century. But here's where it gets even more impressive. The load doesn't just transfer through the beams, it transfers through the rock itself. The temple essentially sits on invisible stone ledges carved into the cliff. The dramatic overhang, you see, that's mostly visual. The real foundation is solid mountain. Now you might be thinking, this sounds too good to be true. How do we know this actually works? In recent years, engineers have used finite element modelling to simulate how this structure responds to earthquakes and extreme wind loads. Even under stress conditions that damage many rigid buildings, the Hanging Temple's structural system remains remarkably stable, largely because it doesn't rely on rigidity at all. Think about that. In simulations, this system performs as well as, and sometimes better than, many rigid modern structures. They built in safety margins that modern codes would be proud of. But this creates an even bigger mystery. If this system is so robust, why does it survive earthquakes that topple modern structures? The answer lies in the third secret. Which brings us to the most important secret of all. Not how the temple resists earthquakes, but how it survives them. Most buildings fight earthquakes. They try to be stronger, stiffer, more rigid than the forces trying to shake them apart. It's like arm wrestling with the earth. Sometimes you win. Sometimes the earth wins. This temple chose a completely different strategy. Instead of fighting earthquakes, it dances with them. Here's the key insight that changes everything. The core structural system relies primarily on interlocking wooden joints instead of nails, screws, or rigid connections. Every major connection point can flex, slide, and absorb energy. Think of it this way. Imagine a skyscraper as a rigid soldier standing at attention. When you push hard, the soldier either stands firm or falls over. There's no middle ground. This temple behaves less like a rigid object and more like a flexible system. Instead of resisting motion, it allows controlled movement, absorbing energy through friction, sliding and compression across many small joints. That's exactly what happens during an earthquake. The traditional Chinese bracket systems, called Dougong, act like shock absorbers. When the ground shakes, these interlocking wooden brackets distribute the stress through controlled friction and sliding. The whole building becomes a giant energy-dissipating machine. Instead of one catastrophic failure point, you have hundreds of small joints all working together to absorb and redirect seismic forces. While many building traditions throughout history chased brute strength and rigid stiffness, Chinese timber design often prioritized controlled flexibility. They learned that flexibility often outlasts strength. This region is seismically active. Over the centuries, many later buildings have needed major repairs after earthquakes. Stone structures cracked, brick walls tumbled, but the Hanging Temple's timber and bracket system still tests as highly resilient in modern computer simulations. It's survived because it's not trying to be the strongest building on the mountain, it's trying to be the smartest. And that leads us to the final secret, the one that reveals these monks weren't just brilliant engineers, they were also master psychologists. Now we come to the most ingenious secret of all, and it has nothing to do with engineering, it has everything to do with human psychology. Remember those vertical posts we talked about? The ones that don't actually hold up the temple? They're not accidents, they're not mistakes, they're deliberate design choices. Here's the scenario. You're a pilgrim 1,000 years ago. You've travelled for weeks to reach this sacred site. You arrive at the cliff face and look up. You see a massive wooden structure hanging in space, supported by invisible forces buried in the rock. What does your brain do? It screams danger. Every survival instinct you have tells you this is impossible. This is unsafe. This is going to collapse and kill you. So the monks gave you something familiar to look at. Posts that appear to be holding everything up. Visual supports that calm your nervous system and let you focus on prayer instead of panic. Whether they did this consciously or not, the result is perfect user experience design. These monks created a psychological interface layer that hides the complex engineering underneath. Many modern architects point to this as the most sophisticated decision in the entire structure. Not the structural engineering, though that's brilliant, the user experience design. It's exactly like a smartphone. All the complex technology, the processors, the circuits, the software, is hidden inside. What you see is a simple, reassuring interface that makes sense to your brain. The monks understood something that modern architects often forget. Buildings aren't just for engineers. They're for people. And people need to feel safe, even when they're experiencing something that challenges everything they think they know about physics. This is psychological engineering at its finest. The fake supports don't just hold up the building, they hold up human confidence. And that brings us to the ultimate question. What can we learn from monks who had nothing but wood, stone, and pure genius? The most unsettling thing about the Hanging Temple isn't that it still stands. It's that once you understand how it works, it feels almost inevitable. Not because it's simple, but because it's aligned with gravity, with earthquakes, with human fear. The monks didn't try to overpower nature. They asked a quieter question. What does this mountain already want to do? And then they built with that answer. Once you see it, you can't unsee it. Every modern building suddenly feels louder, heavier, and less thoughtful. If this kind of ancient engineering fascinates you, click the video on your screen to see how they did it. Subscribe for more ancient mystery and wonders. Till next time.